So now in this video we're going to look at a circuit I came across. So we have a push button switch here. Normally, if you leave it alone, this is a normally open or off a push button switch, then something's off. So we got 0 volts. And then you press it, and we'll press it. There you can see that it actually bounced back. But we went up to 5 volts there. Normally if you let it goes back to the former state. But there you can see that it stayed high. So this isn't a perfect circuit. It will bounce as we saw before. But in any case, now we have it high, the output high. I press the button again, it goes low, and it stays low. So now we'll look at the basic schematic for this circuit. So you want a couple NOT gates. I'm actually using NAND gates. I'm using the same integrated circuit from the last video, the 4011. And you can take a NAND gate and just tie together the two inputs, and then it becomes a NOT gate. So NAND gates, if you have multiple, they can become any other type of logic gates, but with just one you can turn it into a NOT gate really simply. So in any case, we have the NOT gate there. If the output is high, then to the input of that one, then that will set the output of this low to the input of that one. So low, high, low. It locks it into a state right there. It won't change. So we got low now in that scenario, and that's discharging the capacitor right there. It'll discharge. Now that'll put the capacitor to 0 volts sooner or later, and depending on the value of the resistor and the capacitor. We're only using a 10 nanofarad, which is the same as 0.01 microfarad, very low. So in any case, 0 volts now. We close the switch. Remember, that was high. It was 5 volts. We close the switch, and that capacitor has stored charge. It hits 0 volts instantly. And then that sets the output there high, and that output low, 0 volts, which holds it low right there. So now we got this high. We release the switch because remember, it's connected to ground there. We release the switch. Now that high output there can start charging the capacitor, so that next time we press the button, then it will change states again. So the integrated circuit we're using comes from this kit, the 4011 integrated circuit. It is a quad. There are 4 of them, 2 inputs. Each one has 2 inputs, NAND gates, as I said before. So if you look at the part number, it's CD because of the manufacturer, 4011, and then actually says BE after it. But in any case, so we have one of the NAND gates there and the other one there. So that's the 2 inputs for that one, 2 inputs for that one. Those 2 inputs have the output right below them, and these 2 inputs have the output right above them. So bottom pin on that side is ground. That's the negative side of the power supply. And then the top right is VDD or VCC. It'll show up a number of different ways. We're using 5 volts, so that is the positive supply. So here you can see that I got these little metal jumpers right there that are connecting the 2 inputs together on both sides there. So now it's 1 input. That is what it does. Now we have to power the integrated circuit, as we said. So that's the positive supply. We're using 5 volts, but the power's off right now while we build the circuit. And then we got 0 volts right there, ground, negative side of the power supply. So now that we turn the NAND gates into NOT gates right there, let's do the next connection. So we got output to input and then output to input for both of them. So we're going to make basically the same connection. And I got to come to the very top here of the input of that one to go to the output of that one. And it's really easy to short circuit wires and stuff right now. That's why you turn the power supply off while you're wiring that up. So we got the input to the output of the other one, and we're going to do that again. So this time we're going to go to the output first of the top one, and then come down to one of the inputs of the lower one right there, the farthest lowest one. And now we have our 2 NOT gates connected together. So now I left the switch and the capacitor on the board. So switches, you're kind of limited to where you can place them on the board quite a bit. They're always connected on top. They're always connected on bottom. They're separated top to bottom. You have to press the button to connect the top and bottom. So in any case, we got the switch. And at one side of the switch there, we got a capacitor, a 0.01 microfarad or 10 nanofarad going to ground. We already got that wired up. So we're going to take the resistor here, and we can go to either output because we're not committed to this yet. So we're going to go to the output. Let's do the lower one, so we could go down there, and previously I had it to the higher one, but in any case we put it to one of the outputs, which is also the input of one of the other ones because of a jumper, and we go to the switch. So whatever output we went to, that is where the jumper is not going to go. We're going to go to the output of the other one. So actually I think this is how I had it wired up before. And I'm going to slide it off to the side right there. And we go to the other side of the switch, as you can see here. So we got the other output from the resistor, and which is also the input, and it goes to the end of the switch. That's not connected to anything, and you can see that connection right there. And we're done wiring up the circuit, but we want to measure it. So I got my low priced oscilloscope there, and we're going to take the black alligator clip, which I clipped to a jumper there, and we're going to go to the negative supply. So that's our reference voltage there. We're going to look at a voltage in relationship to 0 volts there, ground. And we're going to take the red one and tack it in up here, and you're going to see right now, so 0 volts of course at ground, that's a direct connection. Power supply is not on, so we have 0 volts. So now we're going to turn the power supply on, and you can see that we have 5 volts right there at the power supply. And I think that takes the output, so we're going to go the same one with the jumper there. I think that's also 5 volts. Nope, it is 0 volts. But in any case, we're measuring the voltage where the jumper is, and there you can see I press the button, goes up to 5 and stays 5 even though we turn the button on and off. Now we're going to push it on and off again, and there you can see it goes to 0 volts and stays 0 volts. We're all done. So in any case, hope you enjoyed. This went on a lot longer than I thought I would, but hopefully you still liked it. Make sure you check out one of the other videos I'm posting to the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.